Hey, hello class. This primer is going to be on, as we see here, comprehension with two more advanced data structures, kind of above the Python list level. First is sets, Python sets, and second, Python dictionaries. Now sets, if we remember right, are simply, another collection of elements, just like a list. However, it's got some special features. One is that all of the values are unique. Or in other words, the set is deduplicated. Duplicates are removed. Now, the order technically does not matter in the set. However, when we output it, most IDEs tend to output a set in order. And we'll see that behavior throughout our demo today. So if we were to recall what a set is and how we could use it, let's run through a quick demo. So let's say that we have a list here of values. And we wanted to create a set from this Python list. And remember, a set is going to be deduplicated. So we would first create an empty set. And we do that simply by calling the set constructor. So this creates an empty set. Then we just go through this loop and we extract an element from the list and we simply add it to the set. Okay, so I'll call this temporary variable val, and we'll step through the vals array. And in this case, let's do it where we only extract negative values from the list, negative values. So in that case, I'm sorry, no, let's go positive values. Say we have a whole bunch of these and it goes on, there's -1s and minus, like that. And let's say that we wanted to go through this list and just get the positive values, not negative, let's go positive. Well, we can do that. We just put a simple clause there saying, okay, if the val is greater than or equal to 0, then we would add it to that set. Just like that, pretty straightforward. We'll call the .add method. We will add it to the set. What are we adding to the set? The value that was extracted. So pretty straightforward there. Now, what we can do with set comprehension is, again, rearrange the syntax into a single line of code. So how might we do that? Well, we have to keep this original vals list so we have something to work on. But what we'll do is set 1 here will go where we might expect. It's the target for the assignment statement. Now this time, if we remember from list comprehension, we always use square brackets. Let's switch that up. For a set, we'll be using braces. So there's our bounding set of braces. The first thing that we'll do is establish the for loop for val and val. So that is taking this part of the for loop, actually with the for loop, the for keyword, and putting it right here inside the list or the set comprehension code. What we'll do is simply return value here. We don't want to perform any operation on it. We don't need to manipulate it. We just want that value. But we need that conditional clause here, don't we? We wanted just positive values. So that's going to be if val is greater than or equal to 0. So let's go to some code now and kind of show this in action. Okay, now here's the old school way of doing it, kind of how I just wrote on the whiteboard. Vals is our original array, and it's got a wide variety of both positive and negative integers. Here's our empty set that we'll create. Here is our for loop saying, okay, for every value in values, if that value happens to be 0, then we'll add it to the set. So when we run this, we see here, yep, we get all of this right here. And I should update this code a little bit. There we go. So there's our output. And again, notice that we've got braces around these, so that will denote, in this case, a set and not a list. A list will have the square brackets. So this is all fine and dandy, but the set comprehension way of doing it is going to be this single line of code right here, just like we saw on the whiteboard. So let's parse this real quick. For val and vals was the legacy for loop, and that goes right here for val and vals. The conditional follows it if val is greater than or equal to 0. All right, so here, if val is greater than or equal to 0, it's repeated. And if that's true, well, then what gets returned? And it's just simply val. We're just going to repeat that element into this new list, or I'm sorry, this new set called set1. Now I'm going to run this again, and it'll show the first thing that we output here is going to be this set, and it's going to take all of those values in val, and let's go back up there and make a set out of it. And it'll take only the positive values. So anything negative gets thrown out. Anything that's duplicated gets thrown out. So like here's a 14, and here's a 14. Hang on. Sorry, my dog was drinking out of the toilet, and I don't want her to do that. So we were just talking about how this is going to create the set. And then just for comparison, I'm creating a list variable here also. And I've got the exact same code, except I'm using square brackets. And that's going to create a list of those values. But notice that the output here for these values is not deduplicated. That 14 is displayed twice. And that's because a set is deduplicated, but a list is not deduplicated. A set, as a general presentation, will be ordered, but a list will not be. So that's the difference here. Now let's change our operation a little bit. Rather than just simply outputting the value, let's output the square of the value. So how might we do that in a set? Well, okay, here again, this line of code is going to be bounded by braces and not square brackets. We've got for val and vals, we know what that is. This conditional clause is saying, okay, only if the value is greater than 0 will we perform this operation. And what is the operation? Well, we're just going to square val. Val times val will square it. So we run that, and you see here that we get that output there also, that set. Now here in this case, this set was output, and the order is not guaranteed. Sometimes Python will choose to do it, and sometimes Python will choose not to do it. Here, it chose not to do it. Okay, now this next line of code, let me run it first. is going to actually take this list here, LST. It's going to extract only the even values. So how might we do that? Well, let's do it through, of course, set comprehension. Here is for var in list. So every element through iterating through list is going to be temporarily assigned var. And we're just going to repeat it, no operation on it. And then here's the conditional, if and only if that value is even. And you'll note here that there's a lot of duplicated even values. Like here's a 4 and a 4 and a 4. It goes, there's quite a number. And again, Python set will automatically deduplicate. So that is what gives us this result here with these perfectly deduplicated values. So that's a couple of examples on Python sets. Let's shift gears now to dictionaries. Now, if we remember right, dictionaries are nothing more than, it's sort of a list. But what is the list? Every element in the list of a dictionary is actually a tuple. And a tuple will contain two elements. In this case, the key and the value. Again, it's the key and the value. And if we create an entire dictionary, it'll be a list of these pairs of key value, key value, key value. It's like the traditional phone book, which is just a listing of pairs of name and phone number, name and phone number, name and phone number. Same thing, exact same thing. Now, this code here is showing kind of an old school way to go about manipulating a dictionary. So first of all, here is our input list, just a couple of values there. Our output dictionary is declared in the next line, and this is just an empty dictionary. We're ready to add some tuples to it. Now, in this example, what we want to do is only extract odd values from this list. When we extract that odd value, that becomes a key. And then the associated value that we want is just the cube of that key. So we'll end up with a bunch of odd numbers for the keys, and then the cubes of those odd numbers as our values. So the old school way of doing that would be, again, to put it through a for loop, nice and easy. So for every key in input list here, an input list again is this small list of the integers 1 through 7 inclusive. This is going to filter out and only give us the odd elements. And then if we remember from our dictionary work in COMSC-240, this syntax here will create the key value pair and insert it into the dictionary. It does that by using the index key, and then the right-hand side of that equation is the value. So it's going to put key raised to the power of 3, and that becomes our value. So when we run this, we see now, okay, yep, we've got braces here, again, denoting that we've got a dictionary and not a list. And look at these tuples. The first one is 1, 1. So the 1 is the key, 1 is the value. Here's the next one. Notice we don't have an an even key. These are all odds. We have a 3 here, a 5 here, a 7 here, and those are all of the odd numbers in this original list. And then associated with each of those keys is their corresponding value, and that value is the cube of the original key. So now that's the old school way of doing it. We can do it new school way of dictionary comprehension. Now this code looks pretty dense and pretty kind of intimidating, but let's break it down into its components. First of all, the for loop. For var in input list, we know what that does. It'll iterate through input list every time extracting a value, putting that in our hand, and giving it the label of var. Now there's a clause though, it's only going to do that if and only if var is odd. So the extraction won't even happen for even numbers. Now then, once we have that value in our hand, the question is, what are we going to do with it? And here, this syntax tells us we're going to create a dictionary entry. And we know that it's a dictionary entry because it has got that colon in it. So var becomes the key, and then var raised to the power of 3 becomes the value. So we run this, and you see that we get all of this, just like in the output example. And that's a very sleek way of doing dictionary comprehension with a simple operation on a list of values that originated from a Python list, okay? Now here's another example that I'll show you that works with strings. So here, we're going to have two separate independent lists. One is of states, and one is the capital of those states. So I'm currently recording this in West Virginia, and our capital is Charleston. The next one is Ohio, and its capital Columbus, and then Kentucky is Frankfurt. So here's our new dictionary. We create an empty dictionary, and we will just add values to that. And those values are really just tuples of key and value pairs. Now, the old school way would say, okay, let's put this through a list. I'm sorry, through a loop. So here's our for loop. And what this does, let's take a look at this. If we remember some of the syntax from 140, the zip function here is going to sort of combine those two lists into a single entity, and we can extract corresponding elements, you know, one element from this list and another element from this list, and create a tuple. And those tuples then provide the, what is iterated through. So every time through this for loop, we're going to extract an item from this list and this list, make a tuple out of it, and then process that in the for loop as a tuple. So that's exactly what's happening here. It's going to bind these two lists together, state and capital. And then, rather than for val in vals, here we're saying, all right, what gets extracted each time is a tuple, again, with a key and a value. They're a tuple, so they're bound as a pair. So every time through this loop, we will have key and value. Then we simply add that pair to the dictionary using the standard syntax, where we inject a new element with the new key and then assign it the value. Nice and simple. So we run that, and we see here that we get these tuples of pairs of state and capital. And then let's look at the dictionary comprehension way to do this. Okay, so here's just the new dictionary name that we're going to give it. So we can, kind of move past that, dict using comp. Now this syntax here is a little dense, but let's just go carefully through it. First, it's encapsulated in braces and not in square brackets. So that tells us, okay, dictionary. It'll do a dictionary because we're saying, all right, for every time through, we're going to extract a key and a value. We're going to pair those, and we're going to pair them in dictionary format. Now, here's that for loops zip statement as part of the for loop. So here's the exact same for loop that we had before for key value in zip state capital. That code is just simply repeated here verbatim for key value in zip state capital. Then every time through this loop, it's going to give us that tuple of key and value. And those then are simply inserted into this list. So then when we print out that list, you see that we get the exact same output as this cell above here, which was the old school way of going about placing elements in this dictionary. So we've seen here that that comprehension will apply not just to lists very effectively, but also to Python sets and Python dictionaries profoundly effectively. And we'll be then using all of this in our various coding. Okay, good luck, and I hope this helps. Thanks, everybody.